All right. Hello, everyone. Welcome. Thank you so much for joining us today. We have H window here, and Brice is here, and he's going to walk us through the presentation in just a moment. But before we get started, I do want to take everyone over to Acelab for just a moment to take a look at H window's page. So here we go. All right, yes, and welcome everybody joining. I'm sure people are trickling in. Right now, you can see here we are in Acelab. If you're not familiar, you can use the search bar at the top of the screen anytime you're looking to do any kind of research, really. We've got this new AI search here that's a really unique and great way to do some materials research. However, in this case, if you're looking for a specific manufacturer, you can use this button right here to search for that category. So here we have H Windows page. Got some really great information here. Brice's contact information here as well. Video, value propositions, as well as products. So definitely, when you have a moment, check out their page here. Explore through some of these products to get more information. You can also save it to your firm library just by doing this here. That way you'll have it for future reference. But yeah, there's a lot of great information here. So I will drop the link in the chat for you to check out their page when you have a moment. A couple of other things to make note of before we get started. So this is an AIA accredited presentation. We will get you certificates and credit after the webinar. We already collected your numbers upon registration, so you're probably all set there with that. However, if you're worried we didn't get your AIA number, I'm going to put a form in the chat so you can fill that out and make sure we have your up-to-date number on file. We will also do Q&A at the end of the presentation, so at any point when you have a question or comment, anything like that, use that Q&A button at the bottom of your screen. Drop your questions there, and we will get to as many as we can towards the end. We will also do a webinar poll. You'll see that pop up on your screen as well during the presentation. If you're interested in getting any kind of follow-up information after today's webinar, fill that out. You'll have an email come from Acelab within a few days after the webinar. That's your conversation to get connected with Brice and his team and get some more information. So you can respond directly to the email, or you can log into your Acelab account and you'll find all of those conversations there as well. But again, it's a great way to get any kind of further answers to your questions or just any kind of materials that you're looking to add to your library. But anyways, fill out the poll when you see that pop up if you're interested. And last but not least, we will do a post-webinar survey as well. So we appreciate any feedback that you have on today's presentation. You can leave that there. But that's everything on my end. So Brice, I will go ahead and pass it over to you to get us started.
All right. Thank you so much, Kayla. It's very nice to be here. It's nice to have this opportunity. Thank you for participating and for your interest in what we think is a pretty unique product. Walls of glass have been a staple tool of architects wanting to express transparency, human aspirations, wanting to frame panoramic views, and extend the natural world into habitable space. But for far too long, those walls of glass have come with compromises. In addition to their poor thermal performance, conventional curtain walls have a limited material palette, resulting in mundane, lifeless, placeless cold facades. Timber curtain walls offer an alternative solution where high thermal performance meets authentic beauty and resource stewardship. Timber curtain walls can help you mediate the competing agendas architects are constantly facing, constantly navigating to strike a new balance for facade performance and design expression. So welcome to today's course, Principles for Designing and Detailing Timber Curtain Walls. Like Kayla said, this is an AIA-approved course. You'll get 1 hour of HSW learning units. But about the course here today, we're intending to help you, equip you architects with a deeper understanding of timber curtain walls, the capabilities, configurations, and detailing considerations, resulting in these captivating, sustainable glass facades. We'll do that through kind of 4 general chapters, I'll call it. After doing a brief introduction on timber curtain walls, we'll go into some of the design configurations, structural detailing, air and water control detailing, and integration detailing. This is meant to be part 2. We did an earlier learning unit that you'd be able to find recording of that on Acelab under the resources tab. That goes into more of the kind of the features and benefits of timber curtain wall. So I will touch on some of that briefly and throughout the presentation, but yeah, in general, this is the next step. This is understanding how to actually integrate this product into your projects. So let's get started with timber curtain walls and just a brief introduction of what they are and where to use them, how they're made. The first question is, yeah, timber, but why, right? Timber, for a lot of reasons, is growing in popularity. Certainly with the mass timber movement, we're seeing more and more projects integrating the natural beauty of timber, trying to captivate, have a materiality that's captivating. We also see more and more designers choosing to embrace biophilia and wellness principles, and timber curtain walls can certainly support those design principles. Timber curtain walls are also thermally superior to conventional aluminum curtain walls, primarily because of the material efficiencies gained by low modus of thermal transfer. It also adapts to your aspirations. There are a lot of design freedom abilities in the timber curtain wall system that are lacking in aluminum systems. So, and we'll cover some of those opportunities in today's presentation. So where do we see timber curtain walls? What types of products or projects are typically specifying timber curtain walls? We see them in luxury homes, specifically in places where a client is wanting to capture a view with minimal sightlines. We see it in multifamily and hospitality spaces where the warmth of natural wood is appealing in amenity and resident spaces. We see it in arts and culture and educational projects, again, to express material connections to culture and to growth. And we also see it in civic, government, and healthcare projects, contributing to occupant well-being and environmental sustainability. Really, there are all sorts of projects beyond these that are appropriate for timber curtain walls. But these are some of the project types where we see the most traction currently. So let's get in a little bit more into what they are. Like a traditional, conventional curtain wall, there's a glazing system and there's back members. In a traditional curtain wall, aluminum curtain wall, the back member is aluminum. And in a timber curtain wall, we replace that with engineered wood. These can be softwoods, hardwoods. We can do it in laminated bamboo, and it's also available in FSC certified materials. There are a lot of varieties in the aluminum finishes as well. On the exterior, we have anodizing PVDF paint, such as Kynar, as well as powder coating. So from an exterior, it looks very much like a conventional aluminum curtain wall, again, with a lot of customizations on the finishes. There are a few different ways that we can finish it as well, using either standard profiles that you're seeing on the right side of the screen. There are different cover cap shapes. We can also do it in custom aluminum extrusions, depending on your project, in solid, hollow, and semi-hollow shapes, and wood caps, using, again, it's a snap cover fitting that connects into the pressure profile. The thing with wood is it is a natural material. The one on the screen is a bamboo product, laminated bamboo. But like all natural materials, it will take maintenance over time. One of the beauties of the wood cap, and I'm going to switch screens here to give you a little demonstration of that. So here's that same profile. And if you look down the end of it, you're seeing the aluminum cap, pressure profile, and then there's a clip system. So the wood member is screwed to the clip and the clip is snapped onto the pressure profile. So when you need to maintain this, refinish it, or paint it, you don't have to dismantle the entire system. You just pull off the snap cover, can refinish it. The gaskets stay in place, the glass stays in place. So it's a really easy to maintain system. There are a couple different ways that we can also finish it. Besides the kind of conventional cap system, we can also do it as a silicone glazed system. There are a couple different approaches to this, using a toggle or using conventional silicone glazed components. So the details there, you're seeing a toggle that is mechanically attaching the glass through a channel in the IGU. And then the toggle turns and clamps the glass back into the base profile. And then it's finished with a rain screen sealant. Again, here's what that looks like. This is just acrylic for demonstration purposes, but you're seeing there's a channel and then there's a toggle that is screwed into the base profile. It's twisted in order to lock it in place, and then it's finished with a rain screen sealant. There's also a neoprene gasket in here that acts somewhat like a backer rod for that sealant. And like I mentioned, we also offer it as a traditional silicone glazed, where you're using adhesive silicone to adhere the glazed panels to the base profile. And those are the details on the far right there, both a section, plan section, and then a vertical section. So that's a quick introduction to timber curtain walls and the systems. We're going to talk now about how we design, how we can configure a timber curtain wall system. Like many traditional curtain walls, it can be in rectangular or orthogonal shapes. It's also available in diagonal shapes and sloped shapes. These are a couple projects that are in the works right now. One of the top right corner is an airport project. It's a terminal expansion for the Fargo Airport. The lower image is a health center in Minneapolis that is organized by a tribe, and so there's a lot of Native American icons on the project, including this cone-shaped curtain wall using a timber curtain wall system. So a lot of variability and flexibility in how the system is configured. It can also be used in sloped configurations for glass roofs, but that would be another presentation. Let's go to the next piece. How do we fill in the frame? Like any aluminum system, we can use insulated glass units in double pane and triple pane, spandrel panels, operable windows and doors, as well as mechanical vents. So a lot of flexibility in how you can approach the glazed panels. The glazing pocket itself, the component that adapts to the glazing unit size, varies from 1/4 inch, which you would think of as an interior curtain wall, single pane, up to a 2.5 inch maximum glazing pocket. So there you're talking about a pretty robust assembly, multiple panes of glass, likely impact rated glass as well. Another design consideration in how you're configuring this is what do you do with the corners? We can do inside corners, outside corners, can do them as mitered corners. The image on the upper right there is showing a mitered corner where we use 2 glazing systems attached to one timber member. Typically, those are a little bit wider in order to receive both of those glazing systems. and then finished with an insulated metal panel at the corner. We can also do these as butt glazed corners, but that's again more of a glass system than it is the timber curtain wall system. You're also seeing towards the bottom left splayed corners. We can do that right now. That image is showing a plus or minus 7 degrees. We can go beyond that depending on your project needs. There's a couple of different components that connect in order to make those splayed units watertight. We can also do them as radius corners. And what you're seeing here is drawn as a wider glue laminated member that has been shaped. So depending on the radius, sometimes it would be too tight for a glue laminator to make that radius. So it would be trimmed off of a wider panel, wider plank to create that radius. But just showing you all of the different corner options that are available. I should say, since I mentioned the 3-inch back member, the system comes standard in either 2 1/4 inch sight lines or 3 1/8 inch sight lines. So it just kind of depends on what the structural needs are and what your project goals are. Speaking of structural needs, we can dive into the structural components here. Timber curtain walls use engineered hardwood, softwood, or bamboo, like I mentioned. These have to be engineered components. We can't use just a heavy timber or a 2x4. We need to know how that wood will perform over time. So we need to know the structural capabilities of it, and we need the rigidity that comes with a glue laminated system. Key terminology, and I mentioned this before, back members. So here you're seeing just a quick sketch of the vertical and the horizontal back members coming together without the glazing system. And the size of those back members is all dependent on your project requirements. We take the timber depth is a calculation of your span height, so how high the distance is between your anchor points. We also look at mullion spacing, so the center to center spacing across the facade. We also look at wind loads, how much wind is expected, the pressure of that wind, and then the timber species. Different species perform differently with these structural calculations. Generally, the softwoods and the hardwoods are pretty equivalent in how they manage these loads. Laminated bamboo, usually we have to upsize them slightly because of the deflection criteria. The system goes together pretty seamlessly using a hidden fasteners system. So just a quick video showing how this is assembled in the field. After setting the anchors, the horizontal members are connected using these hidden fastener male and female sides, and these long nail screws lock everything together with that hardware. One thing I should note is that the vertical members are typically the ones that do all of the resistance of the wind loads. So as much as possible, those are the pieces that are continuous, that are we're using for the structural resistance needed. Even in this video, you're seeing the sill is the full depth of the system, and then there's a transom or a horizontal member that is slightly narrower because it's not doing the work of resisting the wind load. It's really there to hold the glass in place. There you can see it. It's really there to hold the glass in place and resist the gravity load of that glass. So let's talk more about these anchors. We can connect a timber curtain wall to a variety of substrates. Wood, either a 2x material or heavy mass timber material. We can connect to concrete, structural steel, and cold form metal framing. So all of your typical standard building structural components can be utilized for connecting to the timber curtain wall. In general, the timber curtain wall is not a primary or a secondary structural element, so it would not necessarily be asked to carry the load of a floor or a roof. It's really an independent structure that's resisting the wind loads and transferring wind loads to the primary structure through anchors. There are a variety of ways that we can do this. I'm going to show you some typical anchor details, and as well as some components I have on the table here too, showing how we can use anchors to resist wind loads, but allow for deflection. So maybe what I'll do is I'll switch here, clear the place. So here you're seeing one of our standard T anchors. This is a steel component that is engineered custom per project. We have slotted connections that connect to the timber, and then we have either bolted connections here, or we can also weld these. If you have a structural steel member, we can weld to. In a typical arrangement, this would be, let's say, at the head, and the timber would slide in here. We would route a receiver for that, so it would slide in here. There would be a gap that's allowing for deflection between the structural member above and the curtain wall, so that any pressures that are being applied, be they a snow load or a live load on a floor, they would not be transferring that deflection into the curtain wall, because we wouldn't like the glass to break. That's usually a bad thing. So that's one of the anchors that we use pretty frequently. Let me switch back to the PowerPoint here so you can see how this gets connected. So here we have our typical rough opening at a parapet. There's a steel structural member, the parapet structure on top of that. From there, we add the anchor. Again, this one is screwed to the parapet cap up there with the slip anchors, the slotted connection. The timber curtain wall comes in and slides into that, and then the horizontal pieces conceal the bolt connection. On top of that, you would start adding your control layers and your glazing, and we'll get into those details in a little bit. So that's one option. We also have the option to cantilever at a parapet condition. Here you're seeing a wind load anchor welded to the perimeter beam of the roof system, again with a slotted connection, allowing for that vertical deflection. At a midspan, this can be either a wind girt, or it could be a floor slab. Here again, you're seeing the structural component, and then when we add a welded connection, this could be a bolted connection, just depends on the engineering of the project. Then add in the curtain wall, this tie-back anchor, bolted through the back member, through the vertical member, and then add in perimeter fire stop and the glazing system. At the sill, we have, again, let's say a knee wall, a concrete knee wall that receives its control layers, thermal and air and water barrier control layers. On top of that, we have the sill anchor. Again, it's very similar to the T anchor I showed. Usually the slots on this one aren't meant for vertical deflection. They're meant for being able to shim and level the system. So the slots are usually a little bit smaller there to provide some tolerance in the field. This one is anchor bolted into the concrete, and we would work through all of those connections and have that completely engineered. So the curtain wall system comes in, various control layers and sealant are applied. The glazing system comes on top of that, and that's the finished system along with some interior finishes coming in. There are a lot of ways to do all of these details, to try to either conceal the curtain wall anchors or to have the back members align with the floor line, or a variety of other ways that we can detail this. But just showing you some standard details to give you an idea of how the system works. The next chapter here is we'll talk about air and water control detailing. There are two different flavors, if you will, of curtain wall systems. There's pressure equalized and water managed curtain wall systems. Each of them have strengths and weaknesses. The system that demonstrating today is called a pressure equalized curtain wall. These are similar to a rain screen, where you have a rain screen layer, and then you have an air barrier layer. Pressure equalization works to prevent water from being driven into the wall system by wind pressure. It works by creating cavity between the outer rain screen and the inner air barrier, allowing air pressure to equalize across that outer surface. So to make a timber curtain wall pressure equalized, several design strategies are used. First is compartmentalization. So the wall is divided into small sealed zones, often per glazing unit, so each compartment can quickly equalize pressure. Here you're seeing just a quick diagrammatic of the gasket system and how gaskets are sealed to allow that air barrier to be continuous on the interior side of the glazing assembly. We also use ventilation slots. These are small vents or weep holes that are placed in the mullion caps and also routed through parts of the pressure profile that allow the interior cavity to allow air to flow freely. And they help match the cavity pressure to the exterior pressure. That airtight inner barrier is on the interface of the wall behind the glazing pocket. And it must be sealed tightly to prevent air leakage. It ensures that pressure equalization happens only between the exterior and the glazing cavity, not through the building envelope. And then a fourth aspect to pressure equalized curtain walls is a drainage path. So here you're seeing that any water that does enter the cavity is directed out through weep holes or drainage channels. These are secondary defenses, since the primary goal is to prevent water entry in the first place. So comparing pressure equalized to water managed systems, water managed systems are designed to accept some water, and they focus on draining it away. So there's no air barrier per se, or not as consistent of an air barrier. The cavity is not sealed, so pressure differentials can still drive water inward. These systems are focused on drainage, so they rely on weep holes and channels to remove water from the glazing pocket. They are slightly easier to fabricate and install, but they're less robust in extreme conditions. So you see them more prominently with storefront systems, conventional aluminum storefront systems, as opposed to curtain wall systems. Their performance is effective in many climates, but less resistant to wind-driven rain than a pressure equalized system. So just a quick chart comparing these things, just to reiterate, pressure equalized systems have an air barrier, water managed systems do not. Pressure equalization is achieved via vents in pressure equalized system, and they're not achieved in water managed systems. Water entry is minimized. In a water managed system, it's expected and it's drained. And the role of drainage in a pressure equalized system is secondary. In the water managed system, it's primary. Pressure equalized systems are higher in complexity for installation than water managed systems, but they're more useful for high performance facades in all climates compared to a water managed system that is more useful in moderate climates. It might be good to kind of walk through some of these gaskets at this point. Have another model for you. This one is showing how the gaskets are lapped. So within each of these gaskets, there are channels that allow water to flow into a drainage path. And then this one here is a bottom sill gasket that has this flap that is wrapped into your flashing details. And you'll see how that kind of works in a little bit later here in the presentation. The end conditions are sealed with silicone with these caps to really create an airtight system. The gaskets themselves are notched in the factory. They come pre-notched in all of the correct locations. So it's really simple to lap these things together and allow the drainage to flow from one area to the next. So with any curtain wall, opening protection is really important, and we'll see how some of these protective layers are used. So preparing the opening, it's often protecting that with a membrane flashing, various layers of metal flashing to create a weather-tight, airtight installation. We'll talk through a few different details here as well on controlling air and water. The roof membrane layer here you're seeing in the light blue color is being wrapped all the way around the parapet and tied into the glazing pocket at the head of the timber curtain wall. An air barrier layer on the inside of the parapet is also tied into the secondary sealant joint. So backing up just a little bit, you're seeing at the head of this, there are 3 different sealant joints. When a system is fabricated and installed in the field, the primary and secondary sealant joints, the primary is on the exterior, a secondary on the interior. So this detail is showing the air barrier connecting into that secondary layer, and then the primary is connecting into the glazing pocket with a finishing sealant, a rain screen sealant at the perimeter of the system. In a jam configuration, again, you're seeing the flashing membrane wrapping the opening and an air barrier connecting. Usually these are connected, and I'm showing this as just a generic barrier. This could be a liquid applied, could be a sheet good, but the key aspect here is that it's continuous, and it's continuous into the timber curtain wall system. So here that air barrier is being returned into the face of the timber curtain wall, and then a sealant joint is closing that off, the primary seal. And then again, a finishing sealant joint on the exterior perimeter. This would be for a mantle panel system. So the sequence of this can change depending on your construction sequence, but in general, this is the principle that you have flashing membrane that's protecting the opening and an air barrier membrane that is connecting to the timber curtain wall. And those principles aren't that different from the sill. Some of the layers may be different. Here again, we're looking at a knee wall, a stem wall out of concrete that receives a waterproofing layer. And then on top of that, a slab vapor barrier layer. And then, oops, one too many. And then we have insulation layer and metal flashing layers that connect over the top of it. On top of that would be the anchor, the timber curtain wall system, again with primary and secondary sealant joints. The glazing comes on top of that, and then a finishing perimeter sealant. Here again, I'm backing up just one step here. That hook that you're seeing on this gasket, that was the flap, the flashing flap that's part of the system. So when water gets into this cavity, it has a way out. So it would weep out through those ventilation holes and drain out through that, that flashing membrane on the gasket. At this point, it might be good to talk through a quick project precedent. For those who have attended the first curtain wall presentation we did, this may be a review for you, but this is still a really good project for us to talk about. This is the Rock Ridge High School in Virginia, Minnesota. It is what's in a particular part of Minnesota called the Iron Range. So it's in northern Minnesota. It's a pretty extreme climate. There's a lot of material history with mining and material extraction, logging in the area. So the design team from Cunningham and DSGW were really looking at a few things for their facade, trying to achieve regional character and express that character. They wanted to use expanses of glass to enliven and attract students to community spaces. And they wanted to invest in the envelope for reduced first and reduced annual costs. And I'll just click through a few different pictures here showing the configurations. Here, there's a lower ribbon window configuration and then upper kind of punched window configuration, all of it done with timber curtain walls. A double high volume on the interior space. The project itself, the way it was able to achieve some of their priorities here, the last one on that design agenda, invest in the envelope for reduced first and reduced annual costs. Oftentimes, high performance buildings command about 10% higher costs than conventional buildings. So the design team worked with the contractor to really understand what the benefits would be of a super tight envelope. And what they found is that they could reduce their mechanical loads and thereby reduce their mechanical equipment and enable them to spend more money and direct that funding towards the envelope so that, sure, the mechanical system is downsized, but you're also saving money year over year on your energy costs. So what they wanted to do is focus primarily on reducing their air infiltration. In this part of the country, the code required air infiltration is 0.4 cubic feet per minute squared. And what they were able to achieve through careful coordination with suppliers, through careful coordination with contractors, is a very tight air barrier. And because of that, their mechanical system was able to be reduced because their HVAC loads were much lower. So the baseline EUI for this type of building in this climate is around 55 kBTU per square foot per year. And Rock Ridge came in at about 45 kBTU per square foot per year. It's nearly 18% higher performing just by making the building more airtight. I met with the architect, the team that did the commissioning, the blower door testing on this a few months ago, and he said they came to the site to test the air tightness and performance of the building. They came to the site expecting to use 5 blower doors to pressurize the building and see how it would perform. He said the equipment was failing. It was too tight. They had to reduce to 1 blower door and like half another one. They had to cover some of the fan. So they were able to pressurize the entire school building with 1.5 blower door fans. So I thought that was a really interesting anecdote, and certainly the timber curtain wall played a role in that, but it was primarily also the contractors being vigilant about any penetrations through these air barriers being sealed properly and finished properly so that it performed as designed and in many ways exceeded their expectations too. So one more aspect on these control layers is also accommodating movement. We talked about in the structural portion how we need to account for deflection of the system, and just wanted to show you a quick detail of a head condition where the deflection may be more than what you could accommodate with a simple sealant joint. So this one uses a deflection channel that's glazed into the system. And then the air barrier layers are looped. So you're seeing that kind of loop here of the system. If it's an adhered flashing membrane, you would keep the tape on, the backing tape on part of this so that it could expand without adhering to the metal panel, the insulated metal panel here, allowing for it to move and flex depending on snow loads or live loads. Other movements that we need to consider are also jam expansion joints. So within the curtain wall itself, certain expanses of curtain wall would require the system to have an expansion joint internally. And so those details are available. We're also looking at jam expansion joints from where the system abuts an existing building, being able to accommodate movement, differential movement between the system and adjacent construction. So movement can be accommodated. Again, it's depending on how your project is designed and detailed. There are a lot of different options to consider there. The last item I want to talk through really quickly, and one that I think is pretty exciting, is integration detailing. This is where we get to have a lot more fun with the projects. There are a few things that we're going to talk about. Number one is accessorizing interior attachments. So this is a project in the Boston, Massachusetts area, a school building that wanted to control how much glare was coming in through their double high volumes in their cafeteria and in their library. So they used an interior light shelf, which redirects the light towards the ceiling, bouncing it deeper in the space and also cutting down the glare. And since this is a timber system, it has the ability to do things that you can do with wood that you can't easily accommodate with other systems. So in this one, we installed these shelf pegs and literally built a light shelf as you would a bookshelf. So there are other ways to detail this too. So you can have hidden fasteners using that same timber curtain wall connector piece, but this was a lower cost way to do that and achieve that interior light shelf performance. There are exterior attachments as well. We have a couple different plates that we can connect to the system. One of them is a socket system. So this is a threaded insert. This piece would get attached to the base profile. You're seeing some of that base profile here and the glazing, the inner gasket around that system. And then it really is just a socket system here that you can do a threaded insert and connect things, a bolted connection that way. Another option that we're showing here as well is a knife plate. This one is a little beefier. So this is an aluminum plate that gets screwed through these holes here into the back member. And one of the benefits of using a timber curtain wall system is, again, you're screwing into wood. So any of the thermal bridging issues that are inherent with using an aluminum system are taken away. Those concerns are alleviated. So this system, oftentimes we provide the plate, and then a glazing installer will drill attachment points to it for like an exterior fin or a solar shading device, solar panel device, connecting into that. The system is still using gaskets to make it weather tight. Any of these penetrations are sealed with a silicone sealant to make sure that you're preventing the air and water infiltration. One thing that's important to talk about with any of these exterior attachments is the structure of them. The coordination is a little bit more intense when it gets into exterior attachments. Structurally, we'll need to know the maximum load applied at each mullion. We'll need to know the maximum loads by the case. So the dead load, snow load, wind loads in all directions. If you think of a vertical fin sticking outboard of the curtain wall, it's going to be catching wind that's kind of parallel to the plane of the glass. And so those lateral forces will need to be accommodated in the design, either through thicker timber mullions, so wider sight lines, or in the way that those timber mullions are connected and tied back to the system. So some of those loads can be taken up in the anchoring devices and then applied to the building structure. So additional coordination is necessary if you're getting into those kinds of options, but certainly doable. Another integration that we're seeing more frequently is electrical integration, specifically with electrified glazing. If you think of electrochromic glazing, similar to sage glass, where it's tinted, controlled tinting, or liquid crystal glass for opacity, the cabling for those glazing systems are generally low voltage. So we can generally run those through the glazing pocket on a timber curtain wall system. I know with sage glass, we found that the thickness of their wiring limits us to probably no more than 5 IGU units connected in any single run, just because we have the bundle of wires there that we need to accommodate the pathway for those. Another electrical integration is powered doors. And here you're seeing a couple options for how those wiring runs can be integrated into a timber curtain wall. The jam detail on the left there is showing a cover cap that has a routing. This cover cap would also be a timber piece that is molded to match the timber curtain wall back member, but it has a channel that the wiring can run into. And then the horizontal mullion there too is also routed to allow that wiring space to connect into the powered actuators. So in general, we would again need more coordination, specifically with penetrations through these back members. We want to make sure that any wiring penetrations are not impacting the structural performance. So again, it would be an item that would be coordinated with the curtain wall supplier and any of the associated trades to make sure that accommodating proper wire sizes. For example, on an airport doors, the gates out to the aircraft those doors are full of devices. They have security devices, they have mag locks, they have low voltage, swipe access. So all of those wires tend to get bulky. So working closely with a timber curtain wall supplier to make sure that those wires are routed properly through the system and maintaining the structural capabilities. So wrapping up, in addition to reducing energy composition or consumption, and reducing embodied carbon, all of the design opportunities with timber curtain walls, there's a lot there, and you don't have to know it all. What I hope you see in this presentation today is that design assistance is available. Timber curtain wall manufacturers have knowledge and resources to help you bring your project to life. It could be system consulting, design resources, thermal analysis, value engineering, and we can be with you every step of the way. At schematic design, looking at system selection, preliminary sizing, budget pricing, into design development, where you're getting thermal analysis or system configuration, refining those sizes, construction documentation, where you may have additional thermal analysis or detailing and constructability reviews, into construction, where the manufacturer is producing shop drawings, integration coordination, producing mock-ups and samples, doing all of the engineering, and then helping the installers with training and support. So with that, I would like to open it up for questions. I hope that you've learned some things, and that you can feel free to connect with us, connect through Acelab if we can't get to your questions here, but happy to connect here.
Awesome. Thank you, Brice. That was wonderful. Let's go ahead and jump into these questions then. First we have, are there configurations with aluminum face cap on the outside and the timber on the inside?
Yeah, that's our typical configuration. And here, I'll just show you a quick view of that here. So where you have the timber system interior, and then you have the aluminum system on the exterior.
Perfect. Awesome. Next question is, how does cost compare to aluminum systems, assuming that the glazing is the same makeup?
Yeah, that's a good question, and I'm sorry I didn't cover that earlier. I meant to. Our system, depending on the configuration, can range from 15 to 25% more than a conventional aluminum curtain wall. Where we see the most competitive pricing is when we get into heights and spans that are greater than 20 feet. Because at that point, aluminum systems are generally adding a bunch of steel. They're having to upsize their extrusion profiles, where for us, we're just adding more wood. So, in those double high spaces, we can be pretty competitive with aluminum systems.
Perfect. All right. And these next two questions, I think somebody was asking on a specific slide, so I'm not sure if we might need more information, but it says in this head/parapet detail, what is supporting the top of the mullion?
Yeah, it depends on the structure of it. Generally, we're kind of hands off on that part. In some instances, we've been asked to be, and I'll just pull this detail up here quick. In some instances, we've been asked to carry the parapet loads by the horizontal loads by the timber curtain wall, but in general, we see more of a detail that's on the screen here, where you're cantilevering the curtain wall up to the parapet than you would the previous version, this one, where we're anchoring to the top of the parapet. In some instances, there's steel that's intermittent in here, and then like a steel plate at the top that we would weld to in that configuration. But
Perfect. That makes sense. All right. Next question is, in the parapet detail, how is that interior air barrier sealant joint installed? Seems like the parapet construction inhibits that.
yeah, so it's all about layering the materials. So just jump to that slide here. So there would be a transition membrane at the top here, where the air barrier is interrupted, and then there would be like a flashing tape or something that connects into that, and then we're sealing against that. Like I said, this is one way to do it. There are lots and lots of ways to do it, depending on your project configurations and what sorts of air barriers you're applying, whether they're liquid or an adhesive product. So
Nice.
happy to answer more about that if you want to talk offline too.
Yeah, that's great. Thank you. All right, and next we have a two-parter. What is the service life of the gaskets, and does the gasket flap completely isolate the wood sill from the air? Thinking about the moisture.
Yeah, so the gaskets are pretty robust. They're, if you're seeing from the even from this view, there's a lot of EPDM rubber there. They last a pretty long time. The system is warranted to the same length as a conventional aluminum curtain wall. So generally, we're seeing a 10 or a 15-year warranty on it, but they're intended to last much longer than that. And what was the second part? Sorry.
Yeah, that's okay. Does the gasket flap completely isolate the wood sill from the air?
Oh yeah. Yes. So that would be jumping over here to the sill detail again. So the gasket does cover the wood. The sealant joint would also cover the wood. So yeah, the wood is protected from any air and water infiltration.
Perfect. All righty, moving on then. Here we have, what sort of vertical spans are capable with a wood curtain wall system?
Yeah, it's a great question. We can do pretty big ones. Again, it's just adding wood to it. I think some of the tallest spans we've done are in the 24 to 28 feet range and beyond. When you start adding mid-span tiebacks, so whether it's a steel windgirt or a floor level that we're tying back to, we can go as high as you need to. Generally, the timbers depends on the species. Softwoods, we can go pretty long, like 40 plus feet in a single span before we start having to splice them together. Hardwoods are a little shorter than that. They're like 24 feet. But the span to depth ratio is very similar to aluminum if you're thinking of it as a non-reinforced aluminum system. So where aluminum starts to kind of edge us out in a span to depth ratio is when you start getting into reinforced aluminum systems.
Got it.
But maybe one more thing on that, and this project I showed, the Rockbridge High School, that one had a 24-foot clear span, and I think the back members were 13-inch deep.
Amazing. Yeah, that's helpful. Thank you. All right. And somebody's asking, do you provide impact/hurricane resistant systems in that product report?
We do not have a hurricane rated system yet.
Okay.
Yep. It's in the works, but not able to offer that yet.
Got it. Okay. And next question is, the precedence project shows savings on the mechanical system. Did that make up 15 to 20% premium to this timber system? If so, is that what you see typically?
Yeah, I don't know all of the specifics on how they did the horse trading. I think it wasn't just the kind of first cost that they were looking at when selecting the timber curtain wall. I think there was also kind of just a project aesthetic that they were trying to achieve. But generally we're seeing more traction in projects where the owners are going to stay in their building for a while. So we're not seeing a lot of developer-led projects where that return on investment is not going to be capitalized by that organization, right? So public projects, private owners, that's where we generally see most of these systems being installed.
Got it. All right. And that was our last question. And we are just about out of time anyway. So, and we actually just got one more. Maybe this one will be quick. Do you use your own proprietary extrusions or do you buy them from someone else?
Yeah, we work with a fabrication partner. We do all of the cutting, the engineering, all of the pre-manufacturing, but the glazing system is Ryco. So that's coming from Germany. So that's the base profile, the gaskets, the hardware connections. So we're manufacturing our product off of that platform. Yep.
Got it. Cool. All right. Well, that's the last question now. Awesome. Brice, did you want to make any final comments before we wrap it up today?
No, I just really appreciate the opportunity to share this with you. Would love to connect. Yeah, talk more about your projects and seeing if there's a match between what you're trying to achieve and what we can offer. So,
yes.
Thank you.
Yeah, definitely. That's great. All right. And yeah, for the folks that filled out the poll that came up on your screen, that is a great way to connect with Brice after today's webinar. You'll have a conversation that'll come in your inbox within a couple days. So feel free to respond to that to get any further questions answered or set up a meeting, anything like that. But thank you so much, Brice, and thank you everyone who joined us today. We hope you all have a great day.
Thank you.
Bye.